good morning, everyone, and thank you all for coming today. Thank you very much for accommodating our detour this morning as well, so welcome. Our speaker this morning is David Marrison, the Associate Professor with The Ohio State University and also the Director of the OSU Extension here in Ashtabula County. And as if you've heard David speak before, you know that he's a wealth of information on many topics, and we're really honored to have him here with us today. In our leadership world, I get to hear David speak on ag typically twice a year in the fall, and I think for probably about 8 or 9 years now, and I learn something new every time. So I know today's topic is very widely debated and of great interest to everyone. So with that, I'll turn it over to David. Thank you.
Good morning. Can you hear okay in the back? Okay, we're a little tethered. I hate podiums, by the way. So I'm tethered, so I'll have to stay here and behave, especially since they're taping it. I think I owe thanks to John Parker, because John Parker at one of our Profiles breakfasts here asked a question about genetically modified organisms, and I deflected the question very well. But so well that it made Laura think, maybe we should do a whole program on genetically modified organisms. So here we are. I saw an interesting video. One of our comedians on TV or YouTube was saying, had a little video clip, and one of those things was going out on the streets of New York City and saying, are you against GMOs? And everybody on the street of New York City, oh yeah, they're bad, they're horrible, they're terrible, there's nothing good about them. And then they asked the next question was, well, what is a GMO? And not one of them could define what a GMO was, what it really was. So I'm here today to talk a little bit of a look at GMOs. I think it'll be interesting to see how much they are in our society, whether we know they are or not, and that's including outside the agricultural realm. I'd like to show a little bit too about what's going on here in Ashtabula County as far as GMOs, give you a little background, and of course I wouldn't do my job if I didn't stir the pot a little bit and give you some food for thought, or give you play the devil's advocate a little bit about, and just ask you some questions for some of those things that you can think about going forward. So of course, you know, if you're talking about GMOs, it's always really good to go out there and take a look on the internet, because everything that's on the internet is, of course, gospel, which we know it's not. But here's the one for Jim Comp. 2 ladies were in Trader Joe's protesting about milk. And you can see it's not food, it's violence. And down in the corner, left corner, can you see what it says? I want to live. Jim, have you ever killed a cow to produce milk? So, and this just opens the Pandora's box of things that are out there on the internet that might not be true. Of course, all of us go to the freezer aisle and pick up our like our old TV dinners. And there's some people in this room who remember the TV dinners. Well, now they have Frankenfood. Hungry Man frozen dinner, microwavable to add carcinogens. Box-raised tortured chicken with tasty GM corn, tomatoes, trout genes, small snail broccoli, human genes, spliced potato. Do you really think this is going on out there? I mean, but these are the things that are out there. Of course, the big boy that is in the public crosshairs about GMOs, of course, is Monsanto, because it's the largest ag company that we have. And of course, there is a millions against Monsanto. And this is an interesting slide, and we probably could spend all day on this. I believe they've attributed everything that has gone wrong in the country, from nuclear weapons to DDT to Agent Orange to BST to PCBs to aspartame in diet sodas to the Iowa caucuses. It's all here about genetically modified organisms. And I'll start to say that I'm not on the left side, I'm not on the right side of GMOs. I tend, and as our university teaches us, to try to be down the middle looking at scientifically based information. And are there things in the past like DDT that we would like to put in the rearview mirror and say, you know, it might have not have been a good idea to use that? Absolutely. There's things that we've done overseas and wars on things that we've used that we'd say, you know what, probably shouldn't have done that. And hindsight is beautiful because it's 2020. But as we move forward, and especially in the GMOs, you have to move forward given the best knowledge that you have today. And maybe in 30 years, we'll look back and say, you know, there's a piece of this that we probably shouldn't have used. But again, hindsight's 20/20. So let's take a look at this. And there's some more. You go out there. You have nothing to do at work today, just type in GMOs. And you're going to see freaky frosted flakes. You're going to see strawberries with eyes. You're going to see test tubes and everything. And of course, we have some of our farmers here. This is how they dress, not when they're planting GM corn, when they got their big spacesuits on. And of course, you have the friendly, nice senior there in the bottom with the organic, growing organics. And of course, remember the children of the corn. Well, if you eat corn today, this is the way you're going to look later in life, children of the corn. And of course, there's always scientific study, and we go right to our squirrels. Yesterday was a good example of going to the groundhog for scientific study. But so we've gone to the squirrel to say, should I eat organic or should I eat GMO? Of course, I've never seen an organic piece of corn that looks like that one on the right, but here's the squirrel, like Vanna White, and which is the squirrel pointing to? Of course, to the non-GMO one, and they would prefer to eat that. And then, of course, I don't think you've lived if you haven't heard the problems with Chipotle. And Chipotle, of course, and I'm always interested in seeing if people are against GMOs, is it because they just don't know what it means, or is there some scientific back behind that? Of course, their new slogan is GM over it, get over it, GMO over it, and their concerns. These concerns are probably pretty valid when you look at them on face value. Scientists are still studying the long-term implications of GMOs. Absolutely, we have to continue to do science. Cultivation of GMOs can damage the environment. That's one that the ag community will have a nice discussion with you. And that gets more into our weed pressures and some of the chemicals that we're using. I would say that some of the chemicals that we aren't using as much are probably helping the environment. And everyone has a real problem with glyphosate, which we all know is Roundup, because I think probably everybody in the room has used Roundup. So if everybody in the room has used Roundup, that should tell you one thing about its relatively safety, the safetiness of it, because they're just not going to put a chemical that does a lot of harm into the average homeowner's hands, where our master gardeners will get a lot of calls back in the days when diazinon and Dursban were on the market, and they will say literally use a tablespoon of this on a big old anthill that might be in your flower bed if you're trying to get rid of these nasty ants. So most homeowners, if it says a tablespoon, will they put a tablespoon? A little is good, which means the whole bottle is going to kill those suckers faster, right? So some of those chemicals that we are using now in greater concentration are actually, when we put them on the scale of safety, they're a lot safer than some of the chemicals that we've used in the past. And Chipotle should be a place where people can eat food made with non-GMO ingredients. Fine with me. And you can see some of the things that they've done about the corn and the GMO corn and the corn and flour tortillas, soy and the tortillas and cooking oil, and of course the meat, they're saying it is non-GMO free for all the meat that you eat in Chipotle, but there's no test that actually proves that the meat that you're eating there has not been fed GMO corn. And President Obama's not even immune from this GMO issue. If you look back to 2007 as president, he said he'd vowed to strive to let folks know where their food is genetically modified because Americans have a right to know what they're buying. Then look what happens in 2013. So the non-GMO crowd, of course, is on President Obama, because who did he place in charge of the Food and Drug Administration? The former CEO of Monsanto. So let's just dive into this and see where we come. I'm trying to put, and Nathan knows because he was over the office, I have like an hour and a half here that I'm squeezing into a half hour for you. But genetically modified organisms, number one, most folks don't even know what GMO stands for, and genetically modified organism is what it stands for. I don't know if that's the best title for what we're talking about. I think it's a poor choice of words, because literally all of us in this room are genetically modified organisms. The moment that your mommy and daddy got together and produced you, you have modified 2 sets of genes. And of course, does anyone know who this just fine gentleman here is? We all learned about him, Gregor Mendel, with the crossing of the P's and looking at heritability and traits. So we've been doing this through generations, and you look at the pretty flower down there, you add two colors of a same family, you cross them and you get a different color. So we've been doing this, and of course if you look back in food through time, the food that we now enjoy, the plants that we eat, whether that be tomatoes or peppers or cabbage, you name it, it all had a source from somewhere from across the world. And when you get right down to it, those sources came from about 10,000 sources. These are some fun facts that you can talk about. 10,000 plant species, but when you really look at what today's 150 of these will make up the diets of the majority of the world's population, but as we go down the list, notice that 12 plants provide over 70% of the world's food, and rice, maize, wheat, and potatoes make over 50% of the food supply. And really there's only 30 crops out there that produce most of the calories, 90% of our calories that go into our body. So you might look at this, would any of you go out and eat this little weed? Sure you are, because it has been bred through time. And some of these vegetables I will admit that I won't eat, but you know, you have your cabbages, you have broccoli, you have these things that why would anybody eat Brussels sprouts? I have no clue. You know, we have cauliflower, you have the colored cauliflower. I know if you roast them in olive oil and blah, blah, they're good. And I still have not seen how that happens. I put that right up there with liver. You know, kohlrabi, all those crops came, even kale. Kale is the rage across the country. Kale came from that weed. That's, and then teosinte. If you look at this is the early origins of corn. Would you eat that? Put that as sweet corn? No, but through modification, genetic modification, we've bred that corn now to go from the early days down in Mexico where it originated, which was truly just a grass plant that maybe a cow would eat, to something that, you know, many of us enjoy sweet corn all summer long. So really, I don't think in the ag public, in the early days, we would say GMO is no different than we've been doing for years. Now, on that definition of GMO, we're absolutely 100% correct. We've been doing this for thousands and thousands and thousands of years. But I don't sense the public thinks and agrees with that's what a GMO is. You know, that's genetic diversity, that's a genetic enhancement. So what are we really talking about when we get into GMOs? And that's more about this definition where the World Health Organization put in. It's basically defined as organism, whether that's plants, animals, could be fish, and the genetic material has been altered in a way that it does not occur naturally, or more importantly, you go to the next line, that's what we would call transgenic. In other words, we're taking a gene out of a species, a different species, pulling that gene and bringing it in, adding it with the genes of that plant or animal that's over here, and then hopefully making that gene better. And I'm not going to go deep into the science behind that. I'll give you one example, but that's usually done through, now you name it, this would be where your test tube, your agrobacterium is the big one in agriculture. So let's look at this happens. Maybe there's two species of flowers, really nice flowers. We genetically modify them through the splicings of genes, and we find an even showier flower that we can add to our landscapes. Or how about the Flavor Saver tomato? Does anyone remember the Flavor Saver tomato? Back in 1994, this was the first GMO food that was available. And the idea is that we're shipping tomatoes across the country. We want those tomatoes that will last longer. So they were genetically enhanced so that the cell walls of this tomato would not break down as fast. Problem is they used a real crappy parent plant, tomato plant, and the taste, the yield, and they actually had some situations where this was actually more delicate than the original tomato that they started with. So this short, and the consumer acceptance, again, as you can probably think about in the early 1990s, was pretty low. So this had a short life of about 3 years and then it was gone. So here's the first one. So I'm swooping through time, and I'll give you the last one that's out on the market now. And this just happened in 2015. You heard it in the news. This is the Aqua Advantage salmon. So those that like salmon, here's a new way to get salmon to your plate. Basically, they've taken a gene out of the Atlantic salmon. They've mixed it with a promoter from an ocean pout, and then they've added to Okay, so they took a gene from the Chinook salmon, added it with a marker, and put it back into Atlantic salmon. And you can see they have 40,000 genes in there. And basically why they've done this is now they have sped up the production process. So now we can get that salmon to your plate in 16 to 18 months, not 3 years. So they've shrunk that cycle. Now, there were some weird things that happened with this as it came through and was accepted. The FDA approved it in November 2015 with the caveat that it could only be produced in Canada and Panama. Okay, so that was a caveat. So as our politicians were getting some feedback on this salmon, and there's quite a lot of feedback if you remember, Target, Whole Foods, you name it, the big food distribution companies all said they would not stock this on their shelves. So it would have to be produced, and that's where it actually has been being produced as far as in research terms. Usually most of that is in Panama. But in the budget bill that was passed in December, there was an import ban placed in that budget bill on salmon from out of the country. So therefore, you're not going to see it for a while here in the country, even though the FDA has approved it. But there is a salmon, and again, this salmon nutritionally is no different than what you would normally get from other salmon. The fact of what they're doing is they're speeding up the production cycle so you're able to get it to your plate faster. Okay, so here's your quiz for the day, and this is where you're going to memorize at the end. This is BT corn, and I can't move here, but this is hard to see, but if you want these slides, just holler at me and I'll send them to you. So we got our little corn plant here, and one of the things as farmers that have to combat is that we have insects and we have diseases and we have weeds in the fields. How do we combat them? So you got the little BT guy here, this little corn borer, just eating away, yum, 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 yum on the plant. Okay, and he does say yum, 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 yum when he eats. Okay, but we know in nature there are certain things that will control and kill like these ear cornworms and other bugs that will get on this, and that's called BT. How many of you use BT in your landscapes? Bacillus thuringiensis, okay? It's on the organic list of things to control insects. So the idea was, okay, it's a natural occurring bacterium. It's there. So the idea was, here is the corn gene. Here in this little test tube, we have pulled apart the gene in the BT, and then we've taken this gene, and then, again, this is David's version of what happens here. It's a lot more complex than this. They take the two genes, they put it together. So now we got the BT gene in the corn gene, so they're mixed together. They take it over here, to the little dish. And then, of course, they're replicating those cells. And as they replicate those cells, then they make new baby corn plants. And then, after years and years of making those baby plants to make sure, and again, farmers aren't going to use this if it doesn't yield like the other corn that they have. And then they put it out, and our farmers grow it. And now when the little bugger comes across there and starts to eat on the ear of corn, what happens? Well, here's what happens. It actually, in the BT, again, it has a scepter in the midgut of the insect. And if you are a visual learner, I'll go through this quick. After they eat and are chewing on this plant, this BT will then go into the gut and makes them sick, then makes them die. Boom. Bug gone. Now, if we weren't using BT corn, how would we control those insects when they became at threshold populations as a farmer? Have to use insecticides. So, and I think most Americans come down, would we favor GMO crops that are designed and engineered like this if it means that instead of out there growing this corn that has the BT gene that will naturally kill the insect, do you want that? Or do you want a farmer out there spraying that crop 4 times with a chemical to kill the insects to help with the yield? That's not a decision I can give you the answer to. That's something you have to think about. Which would you prefer? And the ag side has gone to the point where we would prefer to reduce some of that insecticides and those chemicals that we're using. And then there's studies. Of course, this stuff is being studied. But just in the Midwest, there was 3 states there, and that's really hard to read. But it was $3.2 billion that was saved because of BT corn in those states of Minnesota, Wisconsin, and Illinois. And a side benefit was that the profits went up for the non-BT growers. Why? because there were less bugs out there. That threshold population wasn't there. So insect resistance, it's really hard to look about, hey, are we taking care of the insects? And we have graphs for everything as far as pesticide use, and you'll see why I put some of these in here. When we look at insecticides, we know that we're reducing the amount on corn and soybean, or corn and cotton insecticides, absolutely across the country. You notice what has increased. We're using more insecticides now on soybeans than we ever have before. And why is that? There's this cute little thing called the soybean aphid that comes around every couple years into our soybean fields. And now we have threshold levels that our farmers know, based on the growth of the plant, this is when we spray, this is when we not, or else it's gonna hurt yield. The problem with those little guys, what's their natural predator? Ladybug, right? You guys all love ladybugs, especially the cute little red one. But what's the one you don't like? That nasty orange one that after fall, how it happens? It swoops into your home because it's smarter than the American ladybug, and it overwinters with you. And then when you squish it, yum. And our grape guys love it even more because if you put 4 of them into a box of grape, it will ruin that wine because that taste will go through the wine. So soybean insecticides are up because we're combating this soybean aphid. So if I'm a GMO guy, what do you think they're working on in the background? Instead of using insecticide, what do you see is going to come down the road? A soybean plant that has what in it? A gene that will kill, not the ladybugs, we want the ladybugs. You guys can have all the orange ones. But the farmers wants to get rid of the aphids, and there will be a gene implanted in that so that it will kill it that way instead of an insecticide. Okay, in commonly modified crops, I blew this up for you, and this is on a percentage basis. On cotton, we're at about 90-some% usage. You can see the major crops as far as using GMOs are cotton, sugar beet, soybeans, and corn. And it has different things. An IR means we have plants that are insect resistant. An HT means it's herbicide tolerant. A DT means it's disease tolerant. And a VR, which is important on papayas, is a virus tolerancy. So let's think about the herbicide tolerancy. If you grow regular corn and you plant it out there, and you spray glyphosate, which is again, I can't emphasize enough, glyphosate or / Roundup as we know it, is the safest chemical that is on the whole portfolio of the chemicals that we use. If you spray Roundup on a traditional corn plant, what happens? Or any plant that you're using, what does it do? It dies. So when you're looking to combat weeds, if it has this marker in it, basically the marker in it puts a raincoat over the corn or soybean plant, whatever it may be. It's like a protective raincoat. You can go in and spray Roundup over top that corn. It keeps living because it has that genetic marker that it won't affect it. But then what can we control down below? All the other nasty weeds that we have. Which, and on a profitability side, a farmer may have been spending $35 to $50 an acre trying to take care of these weeds. Now with Roundup, just using Roundup, they can get down to maybe $15 an acre. So as farm profitability, what does that do for your food prices? They go down. Now there's some issues with only using Roundup that we're going to talk about, and you can see what's happened over time here. The soybeans productions and BT, corn, herbicide tolerant cotton, all those things, you can see we're between 75 and 95% now on where a GMO crop is being used in the United States. And I mentioned about glyphosate, that's our major one. And again, there's mixed bags out there as far as how much money, and the big thing is how much money or how much chemicals are we stopping using because of these products. Now, on all the graphs that you'll show, you'll see that we are at current levels or modest increase. What I don't like about these graphs are they don't show you the escalation in acreage that has occurred over the past half decade of the amount of crops. So we're kind of holding steady or going down on total herbicide use, but of course our acreage is increasing. And Again, glyphosate, as an educator, if I had to pick a chemical for a farmer to use, I sure want to see them use glyphosate over something like atrazine, which has a lot more restricted. And you have to know chemicals are based, Roundup is not restricted. That means any of us in this room can go get it. Now there's a product called atrazine, which we've used for years in fields, which is restricted. Has a lot more label warnings, especially with how close you can spray it to water wells and those kind of things. I would sure want people to use the safer chemicals, which Roundup on that, the glyphosate is. Now, if some of you were paying attention last night, I know Nathan Paskey works at night because we're at a beef clinic last night and I get this little text from Nathan, you need to read this article. And Debbie Snook from the Plain Dealer, who many of you probably enjoy Debbie's food articles in the Plain Dealer, she released a nice article about a world report that says more Roundup is being used, and the premise of the article is more Roundup's being used since GMO crops have been around. You know that's absolutely correct. But what the article doesn't tell you is the amount of other chemicals that we have stopped using because we've gone to more of a Roundup, which is safer compound. So that was just in last night's news. A whole big article has come out on this. And of course, our newest thing that's coming out, and there is now we have a soybean plant, this dual enlist duo, which means now they have combined two genes, which on soybean plants we can spray Roundup and 2,4-D. So you have a nice combination that's able to clean up the fields with the different weeds that affect productivity. They're now combined where we can spray this new chemical. There's some registration issues, mainly because it has not been accepted overseas to use, but it's out there. It's our next new thing when it comes to soybean production. You know, as far as who regulates, and I'll go through these quick, we have a lot of different agencies that regulate. The USDA APHIS office determines whether GMOs are safe to release. They're the ones that do that. When you look at the Health and Human Services of the FDA, basically they're the ones that decide, is it safe to eat? The EPA determines that the GMOs that express pesticidal traits are safe for the environment. So they're looking at the impact on the environment. And then if there's the laboratory use of genetically engineered when they're in the lab, they're regulated by the Health and Human Services. So there are agencies that are oversight. Don't believe that there's not oversight of GMOs. So when we are looking at GMOs as far as safety, what do we look at? We look at the direct health effects. Of course, we don't want to feed people food or have something that goes into the food supply that causes problems, especially the second bullet, which means they look at to see if there's any allergens in that. Because again, you're taking, imagine someone with a nut allergy and you've taken and spliced a gene out of a nut and you've put it into another plant. You might be eating, say, a corn-based product that you didn't realize it had that nut gene in it, which then you could have some type of effect to. So they do have oversight and look at that. What's the nutritional toxic properties? The stability of the inserted gene. You say, well, taking a gene, we're putting it over here. When you put those two genes together, what means that it doesn't break apart and it does something weird? So they're looking at that. And nutritional effects, of course, and any unintended effects which could result from the gene being spliced in there. So again, you're looking at, and these are just some facts on as far as the amount of studies that are out there, again, to see do they affect us as humans when we're consuming them. And there's been over 600 studies over the past 10 years that have proven that they're safe, and that's well over 1,000 now. That's probably an outdated slide. And then I think less than 5% cited concerns, and I have that in another slide. So when you look at here in the United States, we are afforded a wonderful food supply, a safe food supply, a very bountiful food supply. So what about those countries that don't? And we know population's growing. So how are we going to feed the future populations, especially those third world countries? And one of those products that's out there now is the golden rice, which adds more beta-carotene and vitamin A into the diet. And of course, there's some other things that are going on. But when you start to look at around the globe, and what you need to look for in this picture are those countries that are marked in red. And that's when we have are places that we have some real nutritional problems. And how are we going to feed those? And this this golden rice is one of those that really could help do some nutritional benefits. And of course, other benefits, we would say we're reducing pesticide usage with better overall weed control. Absolutely, we're doing a better job of doing weed control. Less management effort, and I don't know if this is a good thing or a bad thing, but for farmers, it's made it a lot easier to manage weeds as long as they're making sure that there's no resistancy that pops up. Which, again, just like when a doctor and you go and you get an antibiotic, what does the doctor always tell you? I can't give this to you too much. Why is that? It quits working, right? Same thing with herbicides. If you're not using those right, and we're using Roundup after Roundup after Roundup after Roundup, what do you think is going to happen? We're going to have resistant weeds. Do we have resistant weeds in Ohio today? Absolutely we do. So then we have to find, again, so I say we need more management effort now by farmers because of doing that scouting to look for weeds that might be escaping, that may be building resistancy. And one of our education platforms here as they go through their pesticide training is that we're looking at mode of actions. We put all the chemicals on the board. And mode of actions is basically how the pesticide kills the weed that it's going after. We have to alter the ways that we go after and kill the weeds. We might use this mode one time, the next time we use this mode. I related it yesterday, it's like a game of Clue. All of you have played Clue, right? You know, Professor Plum with the knife in the study, right? So maybe we go after the weed with a knife one time, and then how do we get the weed the next time? With the gun. Or maybe we use the candlestick. So that's what we have to keep reminding our farmers, that we need to look at resistancy the same way. We just cannot keep using Roundup after Roundup after Roundup after Roundup because that builds resistancy. So they have to be really on their top-notch part of their management game. And then there's our ability to meet global demand for food at lower costs. And we hope we are doing these benefits not only for the consumer, but we're doing it for the benefit of the farmer to put more profitability back into their pocket so that they will stay farming, so that we will continue to have the cheap food that we have today. Are there concerns? Absolutely. The allergies that might pop up based on using these genes. The gene transfer. I think probably the biggest thing is the philosophical background. Should we be screwing around with Mother Nature? That's a great conversation to have around with each other. Should we be the ones messing with Mother Nature? I'm not going to, like I said, I'm not going to answer that question. And can we say 100% that GMOs are safe? Anyone who tells you GMOs are 100% safe is saying they're living in la-la land. Anyone who says that they're 100% bad, they're living in la-la land. Everything that we do as Americans has a risk. All of you took a risk today by jumping into your car and driving here. There is that inherent risk of everything that we do. If you don't want any risk, live in a bubble. But we have a risk on everything that we do. So maybe, as I mentioned before, in 10 or 20 years, we might look back and say, you know what? Maybe we shouldn't have used that, i.e. DDT. But given the science and the things that we have in this country, I would push more to the side that says I'm pretty comfortable with their safety. We have problems with potential with outcrossing. In other words, this plant that I'm using here, would it outcross with another plant over there and then create some type of super weed or super plant or something like that? And the resistant weeds and insects, just like the doctor tells us with antibiotics, we have to step up our game in agriculture as far as making sure we don't get those resistant weed populations. And that's why we're here. I mean, that's what we're working with the farmers, we're working with the co-ops to make sure that is something that our farmers are keeping number one on their list as they're controlling weeds. And I think this is the biggest effect, though we care not to admit it, is that we're anti-big, we're anti-monopoly, we're anti-Monsanto. And the biggest thing, no matter what they do, there's always with GMOs going to be a Monsanto effect, like it or not, because we don't like monopolies. So I said I'd stir the pot a little bit, okay? So would you buy a glowfish? Have any of you bought a glowfish? Oh, we got someone in the back says, do you know what? You just bought a GMO. You know that? Because here it is, glowfish were the first genetically modified animal, not for any benefit for us, not a nutrition benefit, not to increase more food. Well, why did we get the glowfish? Because when we stick them in the little tank, what do? They glow. And it's for our pure enjoyment. You know what they did? They went and took a gene out of a jellyfish, grabbed that gene, that fluorescent gene, pulled it out. Who in the heck knows this stuff? I'm going to go grab that gene from a jellyfish. I'm going to sneak it over here in this little triggerfish. And what do we have? A glowfish. So if you say you're against GMOs and you have a glowfish, you're contributing. Would you be okay? And this is in the news. I see a couple cases in Florida on my Twitter this morning, a case in Texas. Would you be okay with a genetically modified mosquito if it helps stop the spread of deadly viruses? What's in the news? Have you gone anywhere without hearing about Zika virus? Okay, and there's a couple other viruses that I can't even pronounce. But this is why they actually developed this little mosquito. Okay, we know that the female mosquito is the root of all evil. Okay. Because which one sucks your blood? It's a female. Because she needs the blood to reproduce. Do the males bite you? No, males are idiots, right? They're just flying around like, ugh, I don't know what to do. So they GMO'd, genetically engineered this male mosquito to do what? Basically to produce sterile offspring. And it's about 80%, it's not 100%. So the question is, instead of, and you see these pictures on TV of them driving down the streets in South America, what are they doing? Spraying chemicals everywhere. They do that in Florida, right? They go down through Miami Beach and they spray chemicals. Do you want them to spray chemicals, or do you want to have this genetically modified little bugger mosquito that's out there flying around taking care of the population by itself? What happens is that mosquito turns into like something weird, right? But what happens if that chemical that they're spraying takes all the hair off your chest and causes cancer, right? And then would you use a cooking oil that is lower in trans fat? You do now, right? Okay, and we've been saying for years, well, use soybean oil. But soybean oil is not very stable. The traditional soybean oil, not very stable. Might not give us the yummy taste of that. You didn't have donuts this morning, did you? That's pretty good. So why not use high oleic, depends on how you want to say it, oleic soybeans. What's the advantage to there? Oleic acid. Look at the saturated. Now, when you look at the saturated fats, which we know saturated fats, bad. There's a reduction in saturated fats. There's an increase in oleic acid, why do we use olive oil? Because it's what? Heart healthy, right? Would you use a soybean in an oil that is producing an oil that gives you the same taste as some of the other oils, but is helping your heart? It's here. Even better yet, if you don't want to use it as an oil, you know what farmers are using with it? It's making hydraulic oil. And it's making other parts that we're putting into tractors. So there it is. It's there. It's out there. And is it okay to modify the T cells in our body to fight cancer? Is it? So we're going in and we're modifying T cells. The T cells will go, burp, burp, burp. I'm going to go find the cancer, and then the theory is it's going to do what to the cancer? Is it okay to, but we're playing with Mother Nature, right? You got to think about it. I would say personal experience, my wife was number 3 patient on a modified T study out of Houston. Didn't work, but you know what? Her goal was, I'm going to be on that study, so 10 years from now, it's going to help somebody else. So, is it okay? And of course, there's other uses that are out there. Potatoes with higher starch content. Where are we getting insulin back in the old days, early 1900s? Out of a dog, right? And then we got sophisticated. We went to the slaughterhouses and we got the insulin out of cows and pigs. So then we've gone to the point that now we're making insulin artificially, right? And our body knows no difference. So is it all right for a diabetic to use a man-made insulin product versus going to a slaughterhouse and getting it out of the pig or the cow that went to the slaughterhouse. So there's edible vaccines in maize, banana, potatoes, a lot more amino acids, maybe healthier oils from soybean and canola oils. And think of the day if I have a nut allergy and we have taken that allergen out of it and I can return once again to eat peanut butter. Okay? And what about our attitudes as I come to a close? There was a study that was done in the past. About 75% of Americans would buy a GMO food if it meant less pesticide use. And about 75% support the FDA labeling of biotechnology foods with health and nutrition information. And that's been the big discussion item. That's about, are we going to label GMO foods or not? And that goes back and forth. They're battling with that in Washington, D.C. But let me give you a little food for thought as far as the labeling. We're saying we got to have labeling. We have to have labeling. When I go in the grocery store, I want labeling. It's got to be there. Well, what has happened to the American consumer? You go back to 1992, which was not that long ago. We used to spend $1.62 in the grocery stores for every $100 that we spent in a restaurant. In other words, $1.62 for every dollar that we spent in a restaurant. What is it today? In 2015, consumers spent $50.475 billion in restaurants compared to $50.46 billion. Put that in the dollar figure. For every dollar that we spend in the grocery store, we're spending more of that in the restaurants. So consumers, if you want labeling in grocery stores, do you want labels in restaurants? Again, I'm not here to answer that question, but you all are eating out a lot. I know it. And so the future, as I look at GMOs, continued research is needed and should be led by non-biased sources. That's university places that have what I would say no skin in the game. Let those advances keep going forward. What are the impacts of new chemicals? And as a farm ag community, that's heightened on our radar as far as looking at what's happening with these chemicals. And do they contribute to the allergies? And we need to know that. And education to both the ag and non-ag public. It would be nice to come back full circle to that skit that they did on that late night talk show where they said, are you for or against GMOs? And then when they asked the next question, what is a GMO? That people would actually know what a GMO is and the different facets in our life that they're actually being used. And I think the debate may not be about the science, and I mentioned this before, but rather is there something wrong in humans modifying nature? Here's a great website as far as for the future, gmoanswers.com. There's a lot of scary things out on the internet, left and right. What we have found, the GMO Answers, is really nice because these are university professionals from across the nation, from land-grant universities that are answering these questions. So if you have a question about a GMO, boom, you type it in there, and then they'll send you a response. It's a really nice place to get what I would say a more balanced portfolio of information as far as what GMOs, the goods and the bads about those. And of course, I have a bunch of resources. Anything that you want on GMOs, it's kind of interesting. So, we're past 9 o'clock, but I'll take a couple questions, maybe. Maybe one question. I said I can't take questions on. No, I can take questions. So I don't know the answer. I'll just deflect it to John Parker. Any questions? Yes.
Can you tell me, or maybe somebody else in the room, tell me what percent of the crops that are grown in Ohio are either genetically modified in the first at all, or specifically from Monsanto or other seed aggregators? I'm not in the agriculture business.
Okay, I can probably answer that. And then on the corn and soybeans, on the soybean side in Ohio, that's probably about 95% of the soybeans that are grown are GMO seeds. In Ohio, that's pretty typical the way the industry is. And the corn is just around 90% of the two major agronomic crops. Now, I will say Northeast Ohio has a pretty strong connection to non-GMO foods because there's a lot of soybeans that are grown in Ashtabula and Trumbull County that are food-grade soybeans that are going directly in to make tofu that are non-GMO that are all leaving Ashtabula and Trumbull counties, being put on boats and going to Japan. So, and you would never know that, but there is a lot of soybeans out of this neck of the woods that are ending up ultimately in Japan as non-GMO. Because in tofu, they have to be non-GMO. So eat your tofu with all you want, because it's going to be non-GMO. Yes?
There was an article in January 31st Star Beacon that talked about GMO labeling, if somebody wants to look it up on the electronic version.
Yeah, there's lots of articles about the labeling. Labeling issue is a real polarizing thing, because how much till we have to have, like on the pesticide label, you know, some of these guys are going to have to read 30 pages before they figure how to use it. So are you going to want 30 pages of what's labeled on what is in that? I think and this is non-OSU, I think our bigger issue is not GMOs. It's what we're putting in our bodies. Okay, so this is not OSU, Nathan. I think my personal philosophy is if you can't read what's on that label, don't eat it. We have put so many things, preservatives, into food to keep the shelf life. I'm more skeptical of some of those preservatives than I'm skeptical of GMOs. This is David talking. This is not Ohio State talking. If I can't read the crap, I'm not eating the crap, right? Just personal, not OSU. And
What about some of the studies that have come out that said that glyphosate was a carcinogen?
absolutely. Is it a carcinogen? Yes. But however, that was a report, and you have to dig deeper in it. It's on the same level of causing cancer that red meat is. So sometimes when they put these reports out, you got to take them with a grain of salt, with saying that Roundup, depending on, could it, anything, if we drink enough coffee, it will kill us. So will anything, yes. Try to do the milk chug gallon where you drink a gallon of milk. You can't do it. You can't do it. But on the Roundup, can it in enough concentration cause cancer? Absolutely. But on the scale of chemicals, if you read that report, it is way down here. That's why the average Joe can use it. But that report somewhere came out of California, and that's been a hotbed issue of the Roundup causing. And the World Health Organization, and that's been fighting back and forth about the release of that kind of stuff. But absolutely it will. It's just at what level would you have to consume it or be exposed to it to get cancer? Good question, Ann.
With all the export of agriculture from the U.S. to the rest of the world, are the EU and some of the others starting to look more favorably on the GMO products, or?
And that's a great question. Is the EU and other countries looking more favorably on GMO products? And that answer would be yes. It's starting to come back, total resistance, to starting to moderate coming back. The big on the endless dual, why is it hung up right now? It's not that it hasn't passed all its tests here under the FDA and such. It's that we're waiting for acceptance from the China market that we're able to send beans over to China. It's every decision that's made on this, it may be perfectly safe here, but it may not get accepted here because we're waiting for our trade partners. And this whole trade thing is weird on how it happens, but that's why this one product, we thought it would be out this spring for there's beans to go in the ground, but it's not going to because it's not been finalized with our trade agreements going over to Asia. So I think you're seeing a sense of that. That's another great question. One more, and then we'll let you go to work for the day.
Not a question, but my niece works at Texas A&M Lab, and they're working on cotton meal because in the cotton seed there is a poison. Humans can't eat the resulting meal after everything's done, which is very high in protein. They've taken that poison out, and there are many generations down the road now on this cotton seed to make sure there's no coming back with it, that it comes back somehow. And if it's successful, which they're positive it will be, there'll be millions of pounds of cotton meal that will now be edible by people in the third world as a food source. Millions of pounds.
And that's a great observation. always blown away when we get stuff that comes across our desk about the research that's happening. I'm blown away that there are people working on each of these little areas and how that may affect us, 20 or 30 years down the road. It's mind-boggling, the science that is out there that's working. So with that, there's my contact information. If you would like a copy of the slides, I can send a PDF version. All you have to do is drop me an email to that email, and I'd be happy to zip it out to you. So thanks again for having me here.
Thank you, David. That was fantastic. So hopefully a lot of your questions were answered and a lot of food for thought today. So next month, our topic is on apps. That phrase, there's an app for that, and how mobile devices are really kind of shaping a lot of things that we do in our world today and what the future looks like for that as well. So thank you all and enjoy your day.